Okay, so I'm just marking this MP2 anonymous student here. So the first question selects 4 tiles out of. So I'm not really gonna write as much as I would if I was marking this, but I might just say all the comments. So the 3 tiles that she starts with are triangles, hexagons, and squares, right? Yeah. Such that these sides are all the same, so they fit nicely, and they're all regular. Okay. Regular means a little bit more than equal side lengths, but in this case, for triangles and squares, it's so triangles it's enough, but squares even you need 90 degrees, for example, here. Okay. So you select 4 tiles. To make 2 shapes, each with 5 sides. That's what a pentagon is, right? Yeah. Pentagon. Okay. You watching? It has a pentagon here. So this student put these 2 as the pentagons. Yeah. So you notice how if you put the square and the triangle, you have 5 sides, right? So that's obviously a pentagon. This one is not as obviously a pentagon because you don't know that this line is straight, right? Okay. So depending on how much you know, you should at least try to justify why it connects straight. So one kind of reason is that this segment here looks just like this segment there, and that's straight here. So basically you're saying it's straight whenever you have 3 equilateral triangles connected together. Okay, so another way is if you know the angle is 60, then you have 3 lots of 60, so you get 180 degrees, which is a straight line. Okay. Okay. So notice that there's no reason given here. And in the marking scheme, it says 2 correct pentagons, 1 mark. Okay, so that's what it looks like. But actually there's a disclaimer at the beginning that says reasons need to be provided to earn full marks, but I think most teachers don't actually know that and just give the 1 mark for the correct pentagons. And the students will never be the wiser. So here, I mean, in some sense, the second answer is a bit tricky, but it's the only one. It's the only possibility left if you tried all the ways of putting 2 of them together. Okay, so this has to be the right one. So a lot of it actually is to show that it's a straight line and making 5 sides. All right. What's the next question? The next question is, this is something you said you did as well, so you should look. Alice took 3 of her tiles, 1 hexagon, 1 square, and 1 triangle, and put them together to make an octagon in 2 ways. Yeah? Yeah. Okay, so this student did it like this, 2 ways. And you can see the one thing is, in general, the pictures are a little bit small. Okay, so when pictures are small, you can see in this part C, it's even hard to make out it's a pentagon. It even looks like it's like a square and 2 triangles. But we can sort of make out the shape, and we just have to count that it has 8 sides, right? So again, the reasoning for part A repeats here to make that a straight line, right? So that's one side, two sides, three sides, four sides, five sides, six sides, seven sides, eight sides. And notice how this thing is not a straight line for that to be an extra side, right?
Yeah.
And similarly here, we rely on this straight line business there to get five sides, like, and then another 3 to 8. So these are fine. But the reasoning for this straight line thing is missing. Okay.
Okay.
And it doesn't mean like it's possible to give the reasons completely at this stage. It's more just an understanding that not all triangles will make a straight line when you paste them there.
Yeah.
Okay. All right. Part C. Are you listening? So Alice took 3 of her tiles, one hexagon, one square, and one triangle. She put them together to make a polygon which has a line of symmetry. Show 2 ways Alice might have done this. Okay, so it might be nice to actually draw in your line of symmetry that makes it at least one. So when it says has a line of symmetry, it's a little bit ambiguous. So I think it means it has exactly one line of symmetry, or it has at least one line of symmetry. It could be both possible meanings. So I think for this age group, it's easier to say at least one line of symmetry, because it's really hard to show why it doesn't have any more lines of symmetry, like properly. But it doesn't mean it's something that can't be mentioned or addressed, okay? So here we have, there's 5, so 1, 2, 3, 4, 5, 6, 7, 8, 9 sides, yeah? And it has a one line, horizontal line of symmetry. How might you argue that it doesn't have any other lines of symmetry? Well, you might consider sort of extreme points and stuff, like we did in the other MP1. Okay, so can you tell me if this is correct? This shape here?
That?
Yeah.
Oh no, because it's a square and triangle here, but the shapes are supposed to be the same. So there's if the shapes are the same, then they can have one line of symmetry, or I mean 2 line of symmetry.
Okay, so what you said is too confusing. Okay, so basically we're looking for two things, yeah?
Yeah.
We're looking for if it's got 9 sides, yeah?
Yeah.
And if it's got a line of symmetry or not, okay? So if those two things are there, then it is right. If they're not there, it's not right, okay?
They're not there.
Well, how do you know?
Because these are not the same shape, so there's no line of symmetry here, and there's no line of symmetry here, but they're also not the same shape.
Oh, hold on, there's this line of symmetry here, right? But see what happens if you don't draw a line of symmetry? People won't know what you're talking about sometimes. But it really is obvious that this is a line of symmetry, right?
Yeah.
So it does have a line of symmetry. Does it have 9 sides? Does it have 9 sides? Can you tell me why?
Because if you put the triangle and square on the hexagon, that's -2, because they're using that side to make 4 sides, and so that is 4 sides. Then 4 sides plus 2 sides there equals to 6, and then another 3 from the square equals to equals to 9.
Yeah. So actually it's correct, right? It has 9 sides. It has 9 sides, and it has one line of symmetry, right?
Yeah. And D is right because it has a line of symmetry here. I mean, like here, and a line of symmetry here.
Yeah. So it has to. It could be an extension problem to show why it doesn't have any more lines of symmetry. Okay.
Okay.
Okay, so part D says Alice put 3 of her tiles together to make a decagon with 2 lines of symmetry. Sure, Alice might have done this. A decagon with 2 lines of symmetry. So what did you say? So is this a decagon? Yeah, so here's a question. I like this question. So it has to use a triangle, a square, and a hexagon. I don't think so. Okay. She just has to use 3 of her
tiles.
It didn't specify. Okay, so here, Michelle, this is really for you. If you wanna look. So is this a decagon and does it have 2 lines of symmetry?
Let me see. Wait, it's not a decagon because hexagon has 6 sides and the square and the other square it needs to use one side to go on there. So that is minus 2 sides, so that's 4 more sides, and 4 plus wait. Oh, it is actually a decagon because if we minus 4, if we minus 2, that equals to 4, and then 4 plus 3 equals to 7, and then 7 plus 3 equals to 10.
Yeah. Okay. Sure. Okay, and then does it have 2 lines of symmetry? Can you tell me?
Yeah, because
Do you know what a line of symmetry is? Line of symmetry is like it's a line where it looks the same on both sides. Okay.
I know.
So like a line like that. See, it looks the same on both sides.
I try. I know.
So show me where the line of symmetry is here.
Can I?
And just talk.
Okay, so the line of symmetry is on top going down. So and the other line of symmetry is going to like straight
That,
horizontally. Because there's 2 squares on the other side, so that is one line of symmetry. And if it's 2 squares on the other side, then there's definitely a line of symmetry up here.
Okay, good. So actually this person also did the extension, which is quite good. So let's have a look. So extension problem here. Alice took 3 of her tiles and put them together to make a quadrilateral with 2 lines of symmetry. Show 2 ways Alice might have done this. See? So the answer for they put was here, kind of right next to these answers, so maybe there were some hints. Okay.
Yeah,
To make quadrilaterals. Okay, so the next question might be more interesting. So can you see that they put 3 squares together to make a quadrilateral?
Yeah, 3 squares.
And you put 2 triangles on the ends of the hexagon. So again, we
can use 4 squares
to justify that that's a straight line, right?
Yeah.
Alice took one hexagonal tile and some triangular and square tiles and put them together to make a dodecagon. Do you know what a dodecagon is?
Dodecagon. 10 sides.
A decagon has 10 sides.
Dodecagon is 11 sides.
No.
10. Is 5 sides? 10 sides. I mean 15 sides? 10.
No, we already said 10 is decagon.
Yeah. 15. So it's 10 plus something. So it's over 10. Dodecagon. 20. What does do stand for? 20.
Do is kind of like, I don't know, it's not close. It's like a little bit far, but it's like duo is 2.
2.
Double is 2.
2 double. Oh, so double 2. So that is what?
No, so dodecagon is 12. I don't really know how the prefix do works, but dodecagon has 12 sides.
Oh.
Okay, so let's have a look at what this person did, okay?
Okay.
So we have here.
Yeah.
That's the hexagon inside, right? But none of the sides come out on the final thing. Okay. So we have to count. So it doesn't look for any lines of symmetry. Wait. We just have to count how many sides it has. Okay, make sure it has 12 sides.
Okay,
okay?
It has
Count with us, okay?
1, 2, 3,
Count
4, 5, 6, 7, 8.
Alright, so this is 1.
Yeah, that's 1. So there's 4 of those, so that is 4 sides. And there is 4 sides too, because there's 4 sides there. So, I mean, wait,
yeah.
it's only 4 sides?
There's 4 sides outside.
Oh yeah, I know. And there's a side in here, and a side here, and a side here.
Yeah.
Side here.
So here, there's a side here, a side here. So there's 4 of those. And there's another 4 of these. Yeah. That's 12, yeah? But as obvious as that seems, I think you still need to justify if that's not a straight line there. So it actually is 2 sides. And remember that thing, it's like that was a straight line here, so that's only 1 side, right?
Yeah, that's 1 side because they're connected.
Yeah, and this part is obvious that there's enough space that these two don't actually touch.
Yeah, so that's a 2 space because there's 2 sides there.
Yep.
So
that's it's still just a few minor things, but that is definitely a dodecagon.
Yeah, because 4 times, because there's 4 of 2, so 4 times 2 equals to 8, and there's 4 sides, which means 4 plus 8 equals to 12, so that's a dodecagon.
Okay, what about this other shape here? Okay, pay attention, okay? What about this other shape?
The other shape?
Yeah.
Like that circle one?
This one. Has this got 12 sides?
It has.
What's wrong? Help us count the sides. We're almost finished.
I'm pretty sure it has only 1 side. I'm pretty sure it only has 1 side because those are connecting, which makes 1 side, and there's no sides in the shape because
yeah, I guess
can't be in the shape.
Okay, so the hexagon tile is in the middle, yeah? So it uses at least 1 hexagon. Actually, it says it uses exactly 1, so both use exactly 1 hexagon, yeah? So this shape, so if we took it for granted as it states, there's 1 for each triangle, right?
Yeah.
Okay. Go. Try and count the sides, okay?
No.
Oh. 你是弄你妹妹吗？
我没有，我秀歌戏的时候，他那个弄我呢，他就 became angry。No，是但是那个你 ask 我这样子。
他抢你的话了，
那个哥哥受抢了。
对，我问他的时候，你就先等他回答嘛，你知道吗？
好。
Okay, Michelle. So we're trying to count the sides. Can you help me count it?
Yeah.
Michelle, can you tell me how many sides are on this thing?
This one.
Yeah. Oh, 不要拿 pencil.
I have pencil to make it easy.
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
Where are you counting? Oh, let's see. So look.
14.
That's 1 here, right?
Yeah.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah.
I thought those make one side because they're still touching.
So yeah, the question is. So there's some interesting things that need to. This definitely needs some explanation. Okay, so this is of another level of not obvious to the other ones. The other ones are actually kind of obvious. This one is not completely obvious because you have a hexagon, right?
Yeah.
And what you're saying is when you put the square on there, right?
Yeah.
And a square on there, a triangle fits in here.
Yeah.
Okay.
Yeah, but then they're touching. But if the triangle goes in, that means they're touching and they're touching. So which becomes one side.
No, not necessarily. So if we draw it far enough, okay. So if you put the square here, square here, right? The triangle doesn't have to be one side. It could be like this, right? Okay, so this is a bit trickier because, okay, obviously if you actually had the shapes, you could just piece them together and it would kind of support what you're saying, right?
Yeah.
But if you didn't, it wouldn't be so obvious.
I mean, if we do the shape thing, it wouldn't turn out like a circle like that one. It would turn out like
So if we draw in our triangles, right?
Yeah.
We have 60 degrees here, right?
Yeah.
60 degrees here, 90 degrees here and here, yeah?
Yeah.
So that's so basically the idea is like 360 degrees is a circle, okay?
Okay.
So what's left over is whatever's not. So this is 90 plus 90 is 180.
Yeah.
180 plus 60 is 240.
Yeah.
240 plus 60 is 300, okay?
Yeah.
So actually the triangle does fit here because there's 60 degrees left. Okay. That's good. So it does fit there, and then this angle here is not 180 because it's 90 plus 60 is 150. So that's not a straight line. So that's good. And I think this just goes all the way around, so that's very nice. Does that make sense? So it could have happened, like for example, if this was smaller than 60, then the triangle doesn't fit in here, right?
Yeah.
If it's bigger than 60, then the triangle doesn't fit nicely in there. The triangle, if it was bigger than 60, it might just look like that, you know?
Yeah, but you can put another triangle in there.
No. It depends on how big it is, right? You can't just say you can put another triangle in there. So, yeah, so there you have it. Let me see. That's it. So this person has obviously done quite well, but there are some issues that need to be raised so that they can continue with their future development. Okay, so it's so in school, this is definitely something that needs to be addressed. Okay, because I see this marking scheme, it might lead people to think that's all there is in the marking scheme, and it's very easy. And also the problem is the marks are too low. So if they're basically right, you just want to give them 1 mark, right? You don't want to take off 1 whole mark for nothing when they're basically right. So there's something like this. It could potentially be worth 3 marks, 1 for each shape and 1 for an explanation. Or if you want to put more weighting to the shapes, you could have 2 for each shape and 1 for the explanation and make it worth 5 marks. Make it worth 7 marks. Have like 3, 3, and 1. You know, a lot of ways to sort of make this question make more sense. Okay, but overall, very good. It's a good mathematical sort of good doing maths. So just need to work on a little bit for the future. Why something isn't right, you know, why this has 5 sides. Sometimes even your drawing doesn't look like that's a straight line. So this drawing doesn't necessarily make that look straight. Okay. Alright, so that's it.